All right, well, if you've made it here, good job. You already understand the gist of substitution. So the next level is that, of course, equations aren't going to come to you already with the first variable solved. So the hardest part to substitution when you really get into it is the very first step, which is to isolate a variable in one of the equations. In the ones you did in part 1, they all had one equation that said y equaled. Now you're not going to have that anymore. So you're going to have two equations, and you're going to have to choose one of the variables that's going to be the easiest to isolate. It doesn't matter which one. You can do any of the four. For example, in this equation, you could isolate this x, this y, this x, or this y. Your answers will come out the same if you do your steps right, but there's going to be an easy way and a harder way. So obviously your goal is to do the easiest way possible. So if you see one of the variables has a coefficient of 1 or -1 invisible, that's the one you want to go for. We're going to solve this one for y, because then I won't have to divide by 5 at the end, or divide by 8 at the end, -8, or divide by 7 at the end, and possibly create fractions. So we're going to get this guy by himself. So you've been solving for y in order to graph things for quite a while, so just be careful, make sure you bring down your negative sign. So you get -7x minus 2. Got to divide by -1 because we don't want to leave it -y. So here's what y equals. Y equals 7x plus 2 in this case. The rest is just like the problems that you already did in part 1. So instead of y, I'm going to put 7x plus 2 in to the other equation. So the one important thing is you have to make sure that whichever one you solved in step 1, you have to use the other equation when you make your substitution. If you plug it back into this one, you're going to get an identity every single time. You're just going to get all the variables cancel out and something like 2 equals 2. It's not going to work. So you have to plug it into the other equation. So then it would look just like it did in part 1. So you're going to put, instead of y, you're going to put in the stuff that is equal to y, 7x plus 2. So there's the substitution right there. Be careful to copy the whole problem correctly. There's what I substituted in for y. So then you'll distribute, and you'll get this. And then you'll combine your like terms. So -8 and 35 would be 27x plus 10 equals -17. And when you minus 10 from both sides, you'll get 27x equals -27, because -17 minus 10 more will be -27. And then when you divide, you're going to get x equals -1. So there's the x value, so you know it's -1 comma something. And let's go figure out what y would be. We'll put -1 in here, back to my boxed area. So y equals 7 times -1 plus 2. This is a -1. 7 times -1 would be -7 plus 2. Y would equal -5. So -1, -5 would be the solution to this system. So this part of the problem is the same as it's always been. It's just step 1. Now you have to take a problem and get a variable by itself to get you going. So here's a second example. Here, I don't have any of the 4 variables that have an invisible 1 or -1. So I'm going to have to make a choice. How you want to choose is, if you can avoid creating fractions, you want to. So you want to think about, if I go for this x, does 3 divide into 8 evenly? No. Does it divide into 12 evenly? Yeah. So at least one of them would go away. If I divide 8, if I choose this one, 8's going to eventually have to divide into that 3. That's not going to work. It's also not going to divide into 12. So I'm not going to pick that one. 3 isn't going to go into 23 or 8. and 8 isn't going to go into 3 or 23. So I'm going to pick this one. It's my best case scenario. I'm going to get this x by itself here because it's going to create the least mess because it will divide into at least one of the terms in its equation. So here's how it would look. So I'm going to get x by itself to get me started. So I'm going to get rid of 8y, and then I'd have negative 3x equals negative 8y minus 12. You have to be comfortable getting either x or y by itself, whichever one you need. So this time, when I divide by negative 3, I would have x equals, this doesn't divide, so I'm going to have to work with 8/3 for my y, but this divides and I would get positive 4. So here's what x equals. So I'm going to have to take that and I'm going to have to plug it in. This green stuff equals x. So I'm going to go to the other equation that I haven't used yet and put it in for x. So I'll have 8 times 8 over 3 y plus 4. Okay, there's my substitution. The stuff that equaled x went in for x. Bring down just the rest of the problem. Don't get worried. You're going to have to distribute to a fraction. That just means these top guys multiply, so you'd have 64 over 3 for your y. 8 times 4 is 32. So when you have to multiply a number times a fraction, you just multiply the top, bring the bottom along. Bring down your minus 3y and your negative 23. And so maybe I'll go ahead and move this 32 to the other side. You could do this now or after you clear the fraction. But the less I have on this side might make it a little bit easier for me to look at. So before I even try to combine like terms, let's see, negative 23 minus 32 would be negative 55. Before I even try to combine like terms, I'm going to clear that fraction because that's hard for me to work with. You guys know how to clear a fraction. So you multiply everything by 3 so that this cancels. So I just have 64y. And now you have minus 9y, and this would be negative, let's see, that would be 150, and that would be 15, so negative 165. Now you can combine like terms. 64 minus 9 would give you 55y equals negative 165. Then you can divide by 55. And you'll get y equals negative 3. So you know that the y coordinate's negative 3. Be careful, pay attention to the letter that you got. Now you have to plug it back in here to figure out what x was. So always go back to your boxed stuff. So x equals 8/3 times, and we know that y is negative 3, so I'm going to plug that in there, and then plus 4. So you can multiply these. You could cancel out the 3's but not the negative, or you could multiply it. How it works is same as over here. You multiply the top. So 8 times negative 3 would be negative 24 over 3 plus 4. Well, negative 24 divided by 3 is negative 8 plus 4. So x equals negative 4. You just could get something like that, and I wanted to show it to you for a worst case scenario. If you get a fraction, just plug it in and work with it. You have to distribute first, but then you can clear your fraction whenever you want to once you get your distributing done. I think I'm going to leave it here because the substitution works the same way. It's just a matter of getting a variable by itself first on step 1 so that you can make a substitution. Maybe I'll just do step 1 on one more problem. Let's see. Is 2 going to divide into 5? No. Will it divide into 8? Yes. 3 won't go into 4, but it'll go into 12. 4 won't go into 3, but it'll go into 12. So I could go for 4 or 3 or 2. It wouldn't really matter. So maybe I'll get this by itself for starters. Just pick one. So negative 4x plus 3y equals negative 12. So add the 4x to both sides. I'm going for y. I had to make a choice. I decided I was going to get this guy by himself. It doesn't really matter which one you pick, because substitution will work the same way no matter which one you isolate. You just have to pick one and do it. So divide everything by 3. So y is going to equal 4/3 x minus 12 divided by 3 would be 4. So there is what you're going to plug in. This would need to go in for y in the other equation. And you'll have to multiply 5 to it, distribute the 5. I'm going to leave it there, but that's how you get started. Then do it the same way you used to. You just might have to clear fractions. Good luck.